I recently captured a really cool moment that I think all of you will like a lot. It was these two specimens merging right here. They met at this point and began the process of fusing. And I pulled out this petri dish and I saw right in the middle they had just fused. Like probably within 5 minutes of me pulling this out and seeing it. And I immediately threw it under the microscope and watched. Okay, look at this. Look at this. This is what it looks like. This tiny little section here that we're seeing. This is probably between 0.5 millimeter and 1 millimeter, something in that. They have just met. Their leading edges have just touched. And look what their very first priority is. They established this primary vein between the two specimens and immediately start sharing contents. You can see the cytoplasmic streaming is what this is called, where they're pumping cellular material back and forth between each other, and some very important things are happening right in this moment, just within a few tens of minutes after they have fused. Now there's two elements of synchronization that are absolutely critical in these first moments. The first one is, of course, just this cytoplasmic streaming. Of course, they're both pumping. It's like heartbeats. They both have this different rate, slightly different rate that they're pumping at. And the difference would actually be larger if these specimens were two very different sizes. But these ones are pretty similar in size, so that probably was not a major challenge. But they do have to synchronize. Because if they do not synchronize, and this cell is pushing its cellular material this way, and this cell is pushing its cellular material this way, at the same time, then they can put too much stress on this vein, and it will pop. Or actually, the alternative, if they're both pulling liquid away from this area at the same time, it can cause too much compression force and similarly cause damage. So this is very important that they synchronize this pumping very early on in the fusion process. The other, and actually more important, element of synchronization that's happening between these two enormous cells in this moment is actually a synchronization of mitosis. They have to synchronize all of the nuclei between both specimens. All of their now shared nuclei have to replicate in synchrony. Isn't that fascinating? And it is quite the show to be able to facilitate this synchronization. One name for this huge cell that does this actually comes from that. It's called syncytia, which is very cool. There are some intense reasons that they have to do that, and I can expand on that later if you want to hear it. But those are the 2 points of synchronization that are happening right now as these two specimens are merging. They're absolutely critical. These have to be executed perfectly. Isn't that interesting? Now, aside from those 2 points of synchronization, there are a few other activities that are very important that are also happening here. One, of course, is resource sharing, which is we already are seeing this, where they're combining their cytoplasmic streaming, and they're sharing food and of course all of their cellular components and resources. But they're actually also sharing information. They're sharing memory. This is so interesting. So I've talked about in other videos, I've talked about how this slime mold has different forms of memory where it can store information and utilize it at a later time. And when 2 or more specimens combine, they actually distribute those memories. They share them both ways mutually across both specimens. And so as they become one specimen, the entire one single cell knows all of the memories that the 2 individual cells knew before fusing, the combined memories, including things like there's this really cool memory system that it has where it can remember ways to ignore or even combat irritants and repellents. Things like salt actually has been utilized as one of these examples in several papers. It does not like salt. It'll stay away from salt. It's a repellent. It can smell it and it will go the opposite direction. But if there's a huge amount of food, or the only food available at the time is beyond the salt, it can actually figure out a way around, figure out a way to go over the salt, not just around it, over the salt, and just ignore it as an irritant or combat as an irritant. When these two cells fuse, it will teach the cell that knows that will teach the other cell that how to do that. Isn't that interesting? Wow, so cool.